So this is your Unit 8 study guide video. I assume you guys can go ahead and get definitions out of your notes, so I skipped that. And then for your topics and skills to know, I had a list of 8 kind of mathematical transitions that you need to know. And so I went ahead and I listed all of them over here to the side, and I have a blueprint for each and every one of them. And all I did was take the piece of the blueprint that was on my board and use the portion that's needed to answer these types of questions. So this would be a good thing for you to use to finish out this study guide, especially if you miss some problems. So now on your mole ratio, it's asking you what the mole ratio of sodium bromide to sodium hydroxide is. So all you have to do is look at your balanced equation. Sodium bromide is a 2, sodium hydroxide is a 2, so this would be a 2-to-2 ratio, which you could reduce to a 1-to-1. So either one of these would be okay. Then the mole ratio of boron oxide to oxygen. So boron oxide is a 2, oxygen is a 3, so it'd be a 2-to-3 ratio. And then for this first math problem, gives you the reaction, and it says how many moles, so your answer should be in moles, are needed to completely react with this many moles. So it's a mole-to-mole problem. So go ahead and write what you're given. And go ahead and write where you want to go, because having your label is part of your points. And if you can get that out of just reading the question properly, those are points that you're not going to miss. So it's a mole-to-mole problem. And you can look up here to find mole-to-mole. We're going from moles of one substance to moles of another. So that would be using your mole ratio, which is up here on number 5 at the top of the paper. So you can look back at that. So if I'm using my mole ratio, but I also use the rules that we've been using this whole time, I take this label and put it in the bottom of the next bracket. And mole ratio, I put the moles of what I want to go to on the top. And use my balanced equation. So moles of oxygen is 3. Moles of aluminum oxide is 2. And then I just have to do my math. And you would come up with 4.22. And since moles of aluminum oxide is what we wanted to go to, everything else cancels out. We're done. For the next question, it gives us the reaction and it asks how many moles. So we know that's our endpoint. Moles of aluminum is what we're trying to get to. And then needed to produce 25 grams of aluminum oxide. So 25 grams is our starting point. And it is a gram to mole problem, so you can go back and look at the blueprint if you are not sure how to proceed. But if you just follow our simple rule of taking whatever label is at the on the top left and taking it to the bottom right until you get to this, then you'll be okay. So grams of Al2O3 in the bottom, and that will go in the top, and that'll be our first step. And then as you can see, moles of Al2O3 are what we're in, but that's not what it asks for, so there's going to be another step after this. But in the meantime, we need to find the molar mass of aluminum oxide. So now that I have that, I'm going to go ahead and move on and take this label down to the bottom of the next bracket. And in this case, I need to switch from moles of my first substance to moles of aluminum, which would be my mole ratio. And I use my balanced equation, so there's 2 moles of that for every 4 moles of aluminum. And now everything is canceled except for moles of aluminum, which matches what I want to get to, so I just have to do the math. And that gave me 0.49 moles. So now reading this one carefully, we have our same reaction. What mass of aluminum is needed? Anytime it says mass, it means grams. So we are looking for grams of aluminum. and then needed to react with 3.2 moles of oxygen, so that's our starting point. So take moles of oxygen to the bottom, and so we can go ahead and switch from moles of oxygen to moles of aluminum here by using our mole ratio. So if I look at my balanced equation, for every 3 moles of oxygen, I'm going to get 4 moles of aluminum. And then we have moles of aluminum here, but I need grams, so I need one more step. So moles of aluminum goes in the bottom. Grams of aluminum can go in the top. And aluminum has a molar mass of 26.982. And now I'm in grams of aluminum, which is what I need, so I just have to do the math, which gives me 115. And then down here, same reaction. What mass of aluminum oxide will be produced? So again, we're looking for grams. We're looking for grams of, if I can write it correctly, aluminum oxide will be produced from 35.6 grams of oxygen. So we have our starting point and we have our end point. So use your blueprint until you get to the right label that you need. So grams of oxygen in the bottom. Take my moles of oxygen down to the bottom now. This is my mole ratio step, so this is where I can switch to my new substance. For every 3 moles of oxygen, I get 2 moles of aluminum oxide. Labels don't match, so I have to go to my final step. Bring this label to the bottom. And my molar mass of aluminum oxide is up here. Now I just need to solve because everything is canceled out except of grams of aluminum oxide, which is what I want, which gives me my answer of 75.6 grams. And then how many grams are there in 5.9 moles of calcium carbonate? So it gives me my starting point, 5.9 moles. And then it asks me for grams of the same thing. So I don't have to change from one substance to another. I just need grams of the same substance. So no mole ratio step is going to be needed here. I just need to take my label, drop it down, and change it to grams. For every 1 mole, I can calculate the molar mass. These will cancel. It'll give me the right label, and I can solve. So that takes care of that. And moving on to the next one, how many moles are there in 85.1 grams of aluminum nitrate? Which that's actually the wrong formula for aluminum nitrate. It should be a 3. And so this time I'm switching to moles of the same substance. So no mole ratio here either, so it's just going to be a 1 step. So I just have to solve for my molar mass and then do my multiplication, or excuse me, do my division, and I'm done. And that will take care of that one as well. So now we're going to get into some where it's talking about some particles, which will help you on the sort of charts that were on your quiz last week. Okay, so I read this problem and set it up. It asks me how many moles of water are in this many molecules of water. So this is my starting point. And so molecules are a type of particle, And for every mole of anything, it doesn't matter what it is, for any mole, it's the same number. Like 1 dozen is 12. Well, 1 mole is 6.02 times 10 to the 23rd particles, which molecules are a type of particles, so that works. And that's how many is in 1 mole of anything. So that will cancel that out, and all I have to do is division. When you type this into your calculator, make sure that you use parentheses. And so this would be your answer in that case. You just do your division. So I've gone ahead and set up this problem as well. It says how many particles are in 17.5 moles of aluminum. So I'm going to go ahead and drop down my label from here to the bottom. For every mole of aluminum, I know that there are 6.02 times 10 to the 23rd particles, which in this case, since it's aluminum, would be atoms, and that's how much is in 1 mole, so I just have to multiply. Now, if we read the next question carefully, it says, in an experiment, she produced this many grams of aluminum chloride. If it's in an experiment, it has to be an actual yield, so I'm going to go ahead and label it actual yield. And then when she performed the calculation, she found the theoretical yield to be 20.21 grams. So that's my theoretical. And it's asking for the percent yield, so I don't even have to find theoretical. All I have to do is actual over theoretical times 100, which is going to be like that. And solve it, and you're done. So on the next page, aluminum and copper sulfate need to react to produce aluminum sulfate and copper solid according to the balanced reaction. So that's the first thing that we have to do, is to write and balance this reaction. So aluminum and copper sulfate react to produce aluminum sulfate, which aluminum is a +3, sulfate is a -2. So if I flip-flop them like this, my formula is going to go plus copper solid. So there's my skeleton. So now I just have to balance, which I'm going to need a 2 here, and a 3 here, and a 3 here. So 2 aluminums on each side, 3 coppers on each side, 3 sulfates on each side. And so now it's asking me for the theoretical yield of copper. So the first thing that I'm going to do is start with 25 grams of aluminum and see how many grams of copper I get from that. So I've worked out that set of math, and that gives me 88 grams. But the thing is, I don't know whether this is the limiting reactant or this is. So I'm going to do another set of math with copper 2 sulfate and see which one produces the least amount of copper, because that's going to be my theoretical yield. So now that I have done that math, and I used both of my reactants to see which one would produce me the least amount of copper with the amount I have, I can see that if I have 25 grams of copper sulfate, it's only possible to make 10 grams of copper. So it doesn't matter how much aluminum I have at this point, because this 25 grams is going to hold me back. So this is actually my theoretical yield right here. So I can put 10 grams up in that box. And then the percent yield of the reaction is again actual over theoretical times 100. Which is actually 116%, which means something went wrong, of course, but we have no way of knowing what it was. So now we have kind of a lab scenario, and it says that we've done this reaction, and we know our theoretical yield is 3.68. Somebody has done the math for us. And then we have the mass of filter paper plus what we produced in the lab. So if we have 5.35 grams of filter paper plus our product, then we can subtract the filter paper and get our actual yield. So 5.35 minus 2.0 is going to give us 3.35 grams, and that is our actual yield. So in order to do the percent yield, we need to take actual over theoretical times 100, which would be 91%. And hopefully you guys, if you haven't already gotten your stoichiometry quiz back at this point, make sure and ask your sub to try to find yours and hand it back so that you can use it to study for the test, because this chart that went terribly on your quiz, you could see something like it again. I have actually already done this chart in a previous video, so I'm not going to do it again. If you actually listen to that video, I describe how to find each and every column of answers. So use that video and use your quiz and try to find your mistakes and solve them. Good luck on your test, guys.